Additional methods on integer types. The integer type implements the numbers.integral abstract base class. In addition, it provides a few more methods. Integer.bit length. Return the number of bits necessary to represent an integer in binary, excluding the sign and leading 0. So here n is equal to 30 bit and n dot bit length. Let me show you. This is the binary representation of minus 37 1000101, and here if I print 100101 100101 minus, so total 336 bits are necessary to represent minus 37 excluding sign bit. So more precisely, if x is non-zero, then x dot bit length is a unique positive integer k such that 2 power k minus 1 less than equal to x less than 2 power k. Equivalently, when abs x is small enough to have a correctly rounded logarithm, then k is equal to 1 plus integer log abs x 2. If x is 0, then x dot bit length returns 0, equivalent to diff bit length. Diff bit length self s is equal to binary self. Okay. And then binary representation bin minus 37 is equal to minus b this, s is equal to s dot l strip minus 0b. Remove this from this string, remove leading zeros and minus sign, returns length s 6. Print bit length n. Six. Yep. So this is the program. Integer dot bit count. Return the number of ones in the binary representation of the absolute value of the integer. This is also known as the population count. Example: n is equal to 19, then bin n dot bit count. So 19, what would be its binary representation? 10011, bit count 1 2 3 3. Yeah. Okay. So equivalent to this, method, print bit count and here n, and then print 3. Integer dot 2 bytes, length is equal to 1, byte order is equal to big, comma, star, comma, signed is equal to false. Return an array of bytes representing an integer. Print 102.2 bytes big. So about 2 bytes. 2 is what? 2. Binary byte order is equal to big. Okay, x04 10 bytes. Hex binary to hexadecimal 04 10 4 digit 10 hex 04 hex 0. 2 bytes 10 2 print 10. Decimal representation of 10 is a, and in binary it's 0 0 0 0 0 4 0. Then this one big sign is equal to 2. Print minus xffffff 1024 04. Then x is equal to 1000 and x dot 2 bytes byte order little print x dot 2 bytes x dot bit length plus 7 integer division 8 byte code little byte order. This was about integer dot 2 bytes. The integer is represented using length types and defaults to 1. An overflow error is raised if the integer is not representable with the given number of bytes. The byte order argument determines the byte order used to represent the integer. The defaults to big. If byte order is big, the most significant byte is at the beginning of the byte array. If byte order is little, the most significant byte is at the end of the byte array. The signed argument determines whether 2's complement is used to represent the integer. If signed is false and a negative integer is given, an overflow is raised. The default value for signed is false. The default values can be used to conveniently turn an integer into a single byte object. 65.2 bytes. 65.2 bytes. 65.2 bytes. A. However, when using the default arguments, don't try to convert a value greater than 255 or you will get an overflow error. Equivalent to 2 bytes and length is equal to 1 byte order big, signed is equal to false if byte order is equal to little, order is equal to range length, else if byte order is equal to big, order is equal to reversed range length, else raise value error byte order must be either little or big. Return bytes and left right shift I multiplied by 8 and 0x ff for I in order. Class method integer dot from bytes byte order is equal to big star signed is equal to false. Return an integer given array of bytes. Print yes integer from bytes 16 little 104096 from byte fc. We need to learn these operations separately, but here we are only trying to understand the functions, how they work. They work exactly how it works in math. Integer from 255 range. Okay. The argument bytes must either be a bytes like object or an iterable producing bytes. The byte order argument determines the byte order used to represent the integer and defaults to big. If byte order is big, the most significant byte is at the beginning of the byte array. If byte order is little, the most significant byte is at the end of the byte array. To request the native byte order of the most host system, use sys.byteorder as the byte order value. The signed argument indicates whether 2's complement is used to represent the integer. Equivalent to d from bytes this n is equal to sum b this integer dot as integer ratio returns a pair of integers whose ratio is equal to the original integer and has a positive denominator. The integer ratio of integers whole numbers is always the integer as the numerator and 1 as the denominator. Integer dot is integer returns true exists for duck type compatibility with float dot is integer. Thanks.